Next type of induction relay is the induction cup structure. In case of induction cup structure, we are having a 4-pole stator as well as a steady or stationary rotor there. So stationary core is there, and on that stationary core we place a cylindrical rotor which is hollow and having one moving contact, as well as along with that moving contact we are having the trip circuit contacts which are normally open. Then as 4-pole structure is there, so we are using 2 windings for producing the 2 different flux. That's why 2 poles having 1 winding, so each winding is divided in 2 equal halls. So there's the first one which is wounded on the opposite poles from the rotor core. The first hall is on one pole and this is the second hall. This is the first winding which we indicate as winding S1. So first winding is there. As similarly for the remaining 2 poles we are having the second winding, again divided into 2 equal halls, and each hall is placed on one pole of the 4-pole structure in opposite to each other. So this is the basic construction for the induction cup relay. This is a directional relay. This will operate in one direction. So whenever actuating signal is given, the I1 will be the current which is flowing from the winding S1, whereas that I1 current will produce the phi1 fluxes which are flowing from the vertical poles, whereas the second current I2 starts to flow through the second coil S2, and that's why the phi2 flux will produced in the horizontal poles. And due to both of the fluxes, the interaction of both of the fluxes with the rotor, the circulating currents will be produced, and that circulating current produces the desired amount of mechanical force on the rotor, and the rotor will be tilted or deflected, and when the rotor is rotated, then both of the trip contacts will be closed and signal will be given to the relay coil. The relay coil will give signal to the circuit breaker coil, and circuit breaker will disconnect that faulty section from the healthy section for the purpose of protection. As soon as the faulty section will be disconnected, then the current I1, I2 as well as the fluxes phi1, phi2 will be vanished, and we are providing the opposing force by using the spring to this rotor. That's why the rotor will be set back to its original position and the trip contacts again get open. As 2 fluxes are there, phi1 and phi2, and they are displaced by an angle of alpha degrees, that's why the net force acting on the rotor is given by F is directly proportional to phi1 into phi2 into sine of alpha.